catastrophic planet-wide tides flood cities, pitch-black nights, an ice age more powerful than Earth has ever seen, and tungsten-shaded evening skies. This is what would happen if we swapped our moon with other moons in the solar system, and spoiler alert, you're not surviving most of these. Let's start this epic show with the truly titanic moon, Titan. You are used to our regular old moon. You're used to its size, the look of its surface covered in gray lunar regolith. What you're not used to seeing is this up in the sky. Yeah, that's Titan. This moon of Saturn is a behemoth. It's the second largest moon in the entire solar system. It's even bigger than the smallest planet, Mercury. Unlike Mercury, it's icy cold. We're talking 180 degree through C, that's 290 degree F. Its surface is covered with rivers, lakes and seas, just like Earth, except that these bodies of liquid are not made of water. That's methane and you shouldn't swim in it. You'd see a big change on Earth if we swapped our moon with Titan. Instead of that silvery white light, our nights would take on a golden orange twilight. Then our new Titanic moon would loom larger in the sky as it's about 1 1/2 times the size of the old moon's diameter. But Titan is a very special moon. It has a thick nitrogen-rich atmosphere that stretches almost 600 kilometers into space. So, our new moon would appear like a giant, fuzzy orange orb. So far, not a big deal unless you hate orange or rhyming things with orange. But things are about to get terrible for you. Titan is 80% more massive than our moon, so its gravity would pull harder on Earth's oceans. Here on Earth, that would be a very big deal. High tides would be far higher and low tides obviously much lower. Now, we can deal with lower tides, but high tides would flood our coastal cities twice a day, every day. There would be more erosion and turbulence on every coast. This would be the only time you'd ever hope you don't own beachfront property because by now, it'd be gone. Things wouldn't be the same for Titan either. After moving all the way from Saturn's orbit to ours, this moon would receive far more solar energy from the sun. It would start to heat up for all the methane on its surface. It would be game over. Titan's methane lakes would eventually evaporate. The icy crust would begin to melt and soon it would reveal the watery subsurface ocean that lies beneath, and that could be a fascinating moment. If any life exists beneath the icy surface in the ocean below, we'd land on Titan's surface and explore it. Now this ocean could be hundreds of kilometers deep, but that just means there's a lot more to explore and maybe a lot more to find. The bad news is, Titan has low gravity. That means it couldn't hold on to all that liquid and atmosphere forever. Over millions of years, it would bleed gases and water out into space, slowly drying out. Yeah, this moon would become just as sad and lifeless as our own moon. Bye-bye, hazy methane orb in the sky. Titan isn't the only thing that's cold and lifeless. Your future could be too if you don't stay relevant to the ever-changing job market. That's where our sponsor for this video comes in, Outskill. Outskill has compressed years of knowledge into an exclusive 2-day AI mastermind workshop. 16 hours, packed with content on AI tools, prompt engineering, automation, and building AI products. No code required. And it's happening this weekend, Saturday and Sunday, from 10 a.m. to 7 p.m. Eastern. Past learners with Outskill have built and shipped over 100 AI products with revenue models earning up to $5K per week. Okay, well that seems like it must have some seriously proprietary information. Must be expensive, right? Well, $900 is what it normally costs, but we've partnered with Outskill to give away 1,000 free seats, completely free, exclusively to viewers of What If, and only for the next 72 hours. With a 4.9 out of 5 rating on Trustpilot, and a free ticket to an AI mastermind workshop, these spaces are sure to fill up quickly. 10 million previous attendees in just the past year alone agree, and now it's your turn. And if you act fast, you'll earn 3 bonuses, valued at $5,000, a prompt Bible with 3,000 prompts, a roadmap to monetize AI, and a personalized AI toolkit builder, again, completely free. Grab your seat now through the link in the description, and learn the skills that will put you ahead of the crowd. This workshop without skill is a big opportunity, and speaking of big things, well, let's get back to the moons and see what other havoc Earth could go through. Now, if you thought Titan was big, well, this moon is gargantuan. The only moon in the solar system bigger than Titan is Jupiter's Ganymede. It's also the only moon in the solar system that has its own magnetic field. It's about 1 1/2 times larger than our moon. So by night it would look about the same size as Titan, only instead of an orangish nighttime, Ganymede would shine extremely bright. Yeah, Ganymede is covered in ice, and that icy surface reflects far more sunlight than our moon does. To you on Earth, this rock would now look much, much brighter. That would be bad for astronomers because they wouldn't be able to see so far into space with this new moon overwhelming the sky, and you might have to invest in some better curtains. Well, that's not that bad so far, but stay with me. I saved the most dramatic part for later. Ganymede is about twice as massive as our moon, and its stronger gravity would unleash worldwide megat tides. Like with Triton, you'd see coastal flooding twice a day, wild erosion and wave activity, and some very destructive storms. Ganymede's presence would be earth-shaking. Literally, its tidal pull on Earth's crust could trigger earthquakes and cause volcanic eruptions worldwide. The one upside, if you're around to see it, Ganymede would stabilize Earth a little. Specifically, it would stabilize the Earth's actual tilt. That would mean no more ice ages and a steady climate forever. So Ganymede itself would start to warm up. Now, you might think that the moon is chilly, but in full sun, it can reach temperatures of 125 degrees C. It's 260 degrees F. Yeah, the moon can get hot. But Jupiter and Ganymede get roughly 130th of the sunlight that the moon does, and Ganymede is usually a chilly -12 degrees C on its warmest days. It's been cold there for billions of years. As Ganymede is heating up, its immense 150 kilometers thick crust of ice would start to sublimate or even melt. This icy rock wouldn't be so icy anymore. It would now have oceans and water clouds. Beneath that crust lies an extremely deep saltwater ocean. Scientists think it's 100 kilometers or 60 millimeters deep. You know, in time you'd go vacationing on Ganymede instead of Cancun. Now Ganymede has its own magnetic field, and it also has auroras. Imagine traveling far north to see our own northern lights, and they're in the background. Ganymede's auroras as well. Pretty cool. Ganymede might destroy everything you know on Earth, but it would also become a pretty inviting rock if you survived all these earthly disasters. Well, you could go live there. Okay, moving on to a hellscape of a moon. Io. Io is the third largest moon of Jupiter, famous for its hundreds of volcanoes blasting molten sulfur lava hundreds of kilometers into space. Io is the most volcanically active body in the solar system because it's subjected to a phenomenal gravitational push and pull between Jupiter and its hefty moons Europa and Ganymede. The tidal forces cause extreme physical distortion and create intense heat, and that heat unleashes itself through endless volcanic activity. Volcanoes and molten lava lakes cover the surface of this virtual inferno, which would make for a pretty phenomenal show the moment we swapped it out for our comparably static moon. Our moon hasn't had volcanoes for millions of years. Io would be spectacular to watch from Earth. By night, it would shine 5 times brighter than our old moon with a golden-orange glow. You'd be able to see Io's volcanoes erupting with a simple telescope. But as hellish as Io might sound, it wouldn't be so bad a companion for Earth. You see, Io is quite similar in size and mass to our moon. You might see a slight increase in the tides, but nothing disastrous. And without Jupiter, Europa, and Ganymede constantly playing a gravitational tug-of-war with Io, the new moon would immediately stop being torn by the three-way stress that heated it mercilessly and caused all those volcanoes. Io would cool down. The volcanoes would go dormant, and our new moon would eventually turn cold and quiet, not unlike our current moon. So, what would happen if we swapped our moon with another famous moon of Jupiter? Next up, Europa. This is one of the most famous moons in history. Since Voyager flew past Jupiter and Europa in 1979, scientists have been intrigued by Europa's icy crust and possibility of an ocean beneath it, which of course opens up the possibility for life. But Europa has even more surprises. Back in the 1990s, NASA's Galileo spacecraft picked up something odd when it was studying Jupiter's magnetic field. Right in the spot where Europa orbits, the field looked strangely distorted. Now Europa doesn't actually have a magnetic field. So where was this disruption coming from? Scientists think this answer lies beneath its icy shell. Europa might have a vast underground ocean of salty water, and as Jupiter's magnetic field sweeps past, it stirs up the electrical currents in that ocean. These currents create a temporary magnetic effect, which is what Galileo detected. This ocean on Europa could be up to 150 kilometers. That's 100 meters deep. It's quite a bit for a moon. For comparison, the deepest depth of an Earth ocean is only 11 kilometers, 6.8 miles. So yeah, swapping our moon with Europa would affect you on Earth. For one, Europa's icy crust would reflect more than 5 times the light that our moon does, and it has a lower mass, so our tides would be weaker. Over millions of years, Europa would make Earth's actual tilt a little more unstable and cause some huge climate swings on our planet. But before Europa had a chance to destabilize Earth, you'd have a better look at it. Okay, now you wouldn't have to send a spacecraft nearly 3 billion kilometers, 1.8 billion miles, to study this moon. At just 385,000 kilometers, that's 238,855 millimeters from Earth, Europa would be just a 3-day trip away. NASA's planning to have people back on the moon by 2027. That means we could have people walking on Europa in just a few years, studying its surface, searching for life. Now, that is cool. Sure, in time, Europa's subsurface ocean would begin to freeze, but Jupiter wouldn't be around to exert the same kind of tidal squeezing it has for billions of years, and its surface would start to warm up, melting or sublimating its ice. Over time, Europa would go from a mysterious ocean world to a frozen, quiet moon. But in the meantime, maybe we'd find we're not the only ones out here. Okay, up next, another frozen moon, but one that doesn't play by the rules. Triton. Triton is a weird moon. It's the largest moon of Neptune, and it's the only sizable moon in our solar system to orbit in the opposite direction of its planet's rotation. The scientists call this a retrograde orbit. Now, if we swapped not just our moon but also the direction it's going, that means our new moon, Triton, is going the wrong way. Triton is another one of these highly reflective, icy moons that would light up the sky. But it's not nearly as massive as our moon, which means Earth's tides would drop dramatically. Instead of the moon being the primary driver of our twice-daily tides, the sun would take that role, and the sun only exerts about half of the tidal force that our moon does. Over millions of years, lacking a strong lunar anchor, Earth's actual tilt would wander more, leading to unpredictable shifts in climate and more extreme ice ages. But when it first shows up, Triton would put on a show. Bright, retrograde, sporting ice volcanoes. That's right. Outside of Earth and Io, Triton is one of the most volcanically active spots in the solar system. Except it's not spewing molten rock. It's venting cryomagma from cryovolcanoes, which is really just a fancy way of saying it's erupting ice up to 8 kilometers, 5 miles into its atmosphere. So we'd have a front row seat every night to watch our moon blast cryomagma out into space. Out by Neptune, it's so cold that the ice on this distant moon is made of frozen nitrogen, water, and methane. Triton's surface is one of the coldest places in the solar system, reaching a frigid 235 C. That's 391 F. Now, being so much closer to the sun, its surface would quickly start to warm up, and all that frozen nitrogen would be vaporized, which could create a thick, hazy atmosphere, maybe even a comet-like tail. Over the centuries, Triton would slowly lose its icy shell, and if it has an ocean beneath it, that would begin to dissipate as well, eventually becoming a smaller, drier remnant of its former shining self. But in its early days, Triton would light up the night and put on quite the show, unlike our next moons, Phobos and Deimos. So far, we've mostly swapped our moon for huge or medium-sized moons, but our next-door neighbor, Mars, sports a pair of satellites that are tiny. Phobos and Deimos are officially moons, but they might just be asteroids that Mars caught in its gravity, and they now orbit around the red planet. The Phobos, the big sibling, is only 27 kilometers wide. That's 17 mi wide at its widest point. Deimos is even smaller, only 15 kilometers, 9 mi across at its widest point. And I say at its widest point, because we can't even get a normal diameter. These moons are completely irregular. They're also more than 100 times smaller than our moon, and they're covered in craters, charcoal, hued dust, and rocks. So, if we swapped our moon for the pocket-sized Phobos and Deimos, paint it black, there'd hardly be anything in the night sky at all. Our new moons would basically look like brightish stars or satellites zipping around in the sky. You wouldn't be able to pick them out of the constellations. Nighttime would be pitch black. Moonlight as you know it would disappear, which would wreak havoc on our nocturnal species across the globe. Good news for astronomers, but for everyone else, swapping out the moon with Phobos and Deimos would be a complete disaster. With hardly any comparable mass, well, the tides would almost be entirely driven by the sun. As oceanic tides drop dramatically, marine life would be so heavily affected that you could actually see the collapse of coastal ecosystems. This would change wind, waves, and global heat regulation. Then worse, over millions of years, Earth would start to wobble wildly. Say that 10 times fast. Earth would start to wobble wildly. This means unpredictable seasons, ice ages, and droughts. Imagine the North Pole winding up at the equator for 50,000 years. Even more, and this one is wild, it could lead to the end of life on Earth as we know it, or at least an extinction-level event. Phobos is slowly falling into Mars. It gets about 2 meters closer to Mars every century. That's 6 FT closer. In about 50 million years, it's either going to break up and shatter into a very small version of Saturn-like rings around the red planet, or it's going to crash directly into it. So, if Phobos is our new moon, well, you'd be looking at a 27-kilometer-wide moon asteroid plowing into us in slow motion. That could be twice as big as the asteroid that wiped out the dinosaurs. So yeah, extinction. Got to say, I prefer our current moon to these guys. Okay, next up, the final moon of this swapping list, Enceladus. Enceladus is a frozen ice ball spinning around the far rings of Saturn, but it's got something cooking under the hood. It's not just riding along on the rings, it's actively contributing to the creation of Saturn's outer E-ring. Yeah, Enceladus is spraying icy water particles and gas into space. What does that mean for you once we swap our moon for Saturn's? Well, Enceladus is covered in fresh ice particles and snow, making it the whitest, most reflective surface in the solar system. So even though it's relatively small compared to our moon, it's still going to shine brilliantly. Nights would be dimmer, but nowhere near as dark as with the miniature moons of Mars. The problem with Enceladus, like any smaller moon we tag in, is that its mass is too small to create the same tidal forces that we're used to on Earth. You got it. So losing our moon and replacing it with Enceladus would essentially recreate the Phobos and Deimos disaster. Cue dramatic drops in oceanic tides, coastal catastrophes, and wild climate uncertainty. And eventually unstable planet tilting, but at least you'd still be able to see at night. Though it wouldn't take long before all that ice started to sublimate and maybe melt. Enceladus's ice shell isn't nearly as thick as some of the bigger moons like Europa, so soon you could see oceans of water on our new moon. Hey, if it means we get another shot to see if life exists anywhere else in the solar system, I'm in. That's pretty cool. In short, swapping our moon with other moons is a neat idea, but if the moons are too big or too small, they'd cause catastrophic damage to our fragile coastlines and most of the planet. So, while I'd love a chance to check out all the volcanoes from the moons of Neptune and Jupiter, I think I'll stick to our good old moon. After all, this is the closest place in the solar system you can deliver a burger to. But that's a story for another Chase Dies in Space.